それではただいまより基調講演のお時間となります。レシーバーについてご案内いたします。チャンネル1が日本語、チャンネル2が英語となっております。そしてこの講演時間は60分で、本日は Q&A は含まれません。ご質問のある方は講演終了後に直接お声掛けいただけたらと思います。本日のキーノートスピーカーはコロンビア出身のソフトウェアエンジニアで PyCon 製ウェブフレームワーク FastAPI の作者として広く知られていらっしゃいますセバスチャン・ラミレスさんです。2018年の公開以来、FastAPI は BMW や NASA をはじめとする世界中の組織で採用され、主要なフレームワークの一つとなりました。2023年にはセコイアキャピタルのフェローに選ばれ、2024年には FastAPI ラブズを創業されています。それでは改めましてセバスチャン・ラミレスさんです。どうぞ大きな拍手をお願いいたします。
Thank you very much. Hello, everyone. This is the first time that I have been introduced in Japanese. We will talk about behind the scenes of FastAPI and Friends for developers and builders. This is me, Sebastián. You can find me online as Triangolo. I created some frameworks. We're going to talk a little bit about it. First, FastAPI. Who has heard of FastAPI? Please raise your hand. Yes, a lot of people. Who has used FastAPI? Nice, a lot of people. Awesome. For those of you that don't know, FastAPI is an open source web APIs Python framework. It's currently the one with the most GitHub stars. Afterwards is Django, then Gin in Go, and then Laravel in PHP. Yay, Python! Now FastAPI has 89,000 stars. FastAPI has been downloaded 4 million, it has like 4 million downloads and 47,000 docs users daily. Yay! So a lot of people using it. This means it's 110 million downloads a month. This is more than Germany's population. It means 5,000 downloads since we started speaking here. So FastAPI was in the last Python developer survey was the most popular. Then it's Django and Flask. It's also been growing on Stack Overflow. So FastAPI stonks, nice. Now, another way to see it is what are some companies using FastAPI? You might recognize some of these logos here. And another way is what are some cool things that people are building with FastAPI? This image was taken from the Webb Space Telescope. And then they send the image to Earth, and they send the science data to Earth, and from Earth, they transfer all the science information around the globe using FastAPI. It's also used for OpenAI, ChatGPT, all the OpenAI images, all OpenAI is using a bunch of FastAPI. It's also used to simulate galaxies in supercomputers. That led to a proposal to observe the first quasar, which is very cool, and I have no idea what it means. It's also used to control particle accelerators at CERN, like the Large Hadron Collider, which is awesome and scary at the same time. So, FastAPI, woohoo! That's why I'm here, because I created FastAPI to give you a bit of reason why would you want to pay attention to anything I have to say. I will tell you a little bit of a mini story of myself and how I ended up here. So I am from Colombia. That's why the accent. But I live in Germany. The same accent with sausages. This is my academical background. This is my last official diploma. Don't get confused by the diploma in Gothic letters. This is from preschool. I'm a kindergarten dropout. I was homeschooled all my life. I got into computers, video edition, music production, graphic design, web development, systems for my parents' small business that they didn't need. I was trying to be this guy, trying many things. Like this, building a website for my parents. Again, this guy. Then at some point, I studied many online courses, and I learned a lot about computers, and it was very exciting. After that, I joined some teams and started working as a software developer, working with teams in different places in the world, with teaching them Colombian slang. Then I got the chance to iterate and iterate and iterate on different types of products that had some similarities. This allowed me to learn a lot of the complexity and how to reduce that complexity using the same similarities from the tools that we were building. Always trying to solve a problem for me, for my team, for the product, and for everything. This is what led to the tools that I have created. Always trying to solve a problem. This is an idea I have, maybe controversial. I think the focus on innovation is wrong. The focus should be on solving a problem. Innovation is a side effect of solving a problem. And to do that, you have to become a power user first. You find a technical problem that you want to solve, a problem, hopefully, that is important to you, and then you study the tools to solve that problem. Sometimes there are no courses, only manuals, only docs, but studying those tools, you will be able to apply them to solve that specific problem. The main point is to solve a problem, like this guy. So if you remember anything from this talk, is to go and solve a problem, focus on solving a problem, and go and solve a problem. That's all you have to remember. Now I'm going to give you tips for building a product, things that I have learned when building these frameworks and things like that. The first is build what needs to be built. And actually, this includes don't build what doesn't need to be built. So first, find the problem that you want to solve. If it's not solved yet, then it will make sense to solve it. In many cases, it's already solved, and you just have to find the tool and apply it to the problem, and that's it. But maybe the problem is not solved yet, and maybe there's a previous problem, and then you have to go and solve that previous problem. And for that, always you can try to use other building blocks. Is that problem, the previous problem, is it already solved? Then you can apply those building blocks that already exist there. And you can use open source for that. In many cases, that can be very helpful. There are some other cases where there is some solution, but maybe the current abstraction layer is too low. Or maybe the cost of learning your new tool, the new thing that you can build, will be much lower. It will be much easier to learn the new thing that you can create. Or maybe the convenience of the new thing that you are creating could be much higher. In these cases, the difference between what already exists and what you are going to build should tip the scale. But actually, no. It should not tip the scale. It should trip the scale. So it should not look like this. It should look like this. The solution that you are creating should be so much better than what is already there for it to actually make it worth it to go and build it. The next tip, optimize for the user, not for the maintainer. The first thing is to adopt the point of view of the user. You can design the user experience first, and then build the internals of your tool to fit that user experience. For example, auto-completion depends on type annotations. If you are building Python tools, having those type annotations is what enables auto-completion. The same with inline errors. Those depend on type annotations. For example, when you are creating a function, you can use explicit parameters instead of quarks. Let me give you an example of that. Let's say you have a function process. You can say, oh, this receives quarks. This is just going to be a dictionary that can take anything. And inside of the function, you extract from this dictionary name and use it. This is very powerful, very dynamic, and very inconvenient for the final user. It looks like this. The final user tries to use this function. If they trigger the tooltips, the editor is not going to know what are the parameters that they can use. If they trigger auto-completion, the editor will say, quarks is not very useful. So this is not a great developer experience. Maybe you have heard they say, if it quarks like a duck, then it's a duck. But this is not really a good duck. Instead of this, you can define the type annotations in the function. Now, when the users try to use this, they are going to see that there's a parameter name that is a string that by default is world. And when they trigger auto-completion, the editor is going to be able to help them. So if your user needs to hammer a nail, don't give them a wrench. Give them a hammer. Now, standards can be helpful, but reading them might be boring. But you can get free interoperability. Still be aware of non-use standards. There are many standards that are not really used. And there are also other things that are not really specified in a formal document as standards, but they are used everywhere. The next tip, capture a smart newbie. If you see a smart newbie that is willing to help you, throw them a Pokeball. They have fresh eyes, nothing is obvious yet for them, and they will help you find voids of information, and will help you adopt the newbie's point of view. Now let's talk about computer science hard problems. The first problem is caching validation. The second is naming things. So first, caching validation. Let's talk about reducing the information duplication. Let's imagine that we have a class that defines the shape of the data in a database. We also can have a class that defines the shape of the data that will be used in APIs. We have a lot of information duplicated here. In one side, we say ID is an integer, and in the other side, we say ID is an integer. This is the same information. It's not the same as code duplication, because the code is actually different. And this could apply to variables, to configurations, configuration files, but this is still duplication of information. It's like a cache. If you change this, then this code is not really longer valid. This is supposed to be a copy of the information that is defined here. So let's say that we decide that we changed ID to be a UUID. Now this is actually invalid. This should be changed, and now should be a UUID. So we have to invalidate that cache manually, just writing code. You can try to avoid that. For example, I built a SQL model to try to avoid that information duplication. And you have one single class that has the information that you could use for many things, like for interacting with the database or with APIs. There are some other cases where duplication is needed. In those cases, you can try to keep it close. That will help reduce out-of-sync problems. For example, in FastAPI, you say that there's a path parameter item ID, and then you use that path parameter inside of the function. We are duplicating this information here and here. It's here and here. Then if you, let me go back. If this piece of code was in one file, and this piece of code was in a different file, it will be much more difficult to figure out that this changed. If you decide to change it, then you have to remember that they are in different files and go and change it there. If they are on the same file, one line of distance, it will be much easier to find that this changed and then being able to update it here. So having information close when it needs to be duplicated can help you reduce those bugs of out of sync. If you have multiple things that look the same, you can just eat one or try to keep them close. Now about naming things, you can try to reduce ambiguity. Avoid different things with the same name. This is sort of the contrary. This also applies to code, docs, configs. Let me give you an example. This is an open source project I created a long time ago. It was somewhat useful for deploying Flask in Docker. At some point in the documentation, I had this example. You have one directory that has some files, and another directory that has Python files. Both have the same name, app and app. This makes things so difficult. Then I had to explain what each one of those means. And I had this, you don't have to read it, I will highlight. There's one type of app. There's another type of app. So this one is the directory where everything is inside. And this is the actual Python package. And to make things worse, there's another type of app. There are 3 things called app here. It's very difficult to explain this. It's very difficult to think about it and to communicate it with others. So you can try to avoid having several things have the same name. It's like this folk is trying to get Turkey, but this is Turkey and this is Turkey. It's not clear what to get. Next tips for writing good documentation. Explain what needs to be explained before. You explain something, and then you realize there is some previous concept that should be explained. Then explain it before. This will help you create sort of a graph of concepts. Some things need to be explained before, just explain those things before. And then explain everything. And then reread, rewrite, clean, and trim down the documentation that you were writing several times until you are happy and you are not making more changes. And then reduce the duplication of concepts. Try to reduce the amount of things that need to be said. The idea is to get the users to apply the minimum effort to get the maximum value. This is the whole point. More tips. You don't have to read any of this. This is just example. You can use space, graphics, emoji, notes to help with the documentation. For example, this paragraph and this paragraph and this paragraph, they could all be together. They could be a single long paragraph. But having space between them helps the eye and the brain know that there's a separation of information here. And the emojis can also help, it's like a little piece of candy for the brain. So if the brain finishes reading this, it can get this little piece of candy. In the end, it's just information, but it can help. Also keep consistency for the terms and concepts that you are using. If you are saying something that is supposed to be code, then you can format it like code and keep consistent format for that same information that you have there. If I say something is a table model, I should keep saying table model everywhere. If I start saying database model instead of table model, the users could get confused thinking those are two different things. And I was actually referring to the same thing. You can also use, so this is about the consistency of the names too, and you can also keep consistency for the style of those terms and concepts. If you're using bold for something, you can just keep using bold. If you're using a code style, then you can keep using that. The idea is to make it very simple for the newcomers, and then afterwards, you can enable power users. But this, making this easier for the newcomers, that should be the first part. Then you can also try documentation-driven development. The idea is, this is what I did for some of the projects. I created first the example code, and then the documentation and the explanation for that example code, and then I implemented the internals to actually make it work. Before, I did that after creating the examples. This helped change the design to make sure that it was very easy to follow, very easy to understand, and very easy to explain. If it's easier to explain, it's normally easier to think about and to work with it with teammates. The other thing is, if you have code examples in documentation that you are showing in your product or your project, you can also test those code examples. This helps make sure that whenever you copy and paste one of these examples, it's always going to work. This is the case for FastAPI, SQL Model, Typer, and all my projects. This will also help ensure that your documentation is always up to date. So you can use all the tools that you have at hand to make the documentation pleasant. The documentation is the way that you communicate the tool and the product that you are building to your users. And that communication is very, very important. Now, premature abstraction is dangerous. You might have heard that premature optimization is dangerous. I think that premature abstraction can be even more dangerous. You can try to reduce the constraints and the abstraction layers that you have to deal with. You might have seen things like this: a class that calls another class method when it could all be a single function. And you actually didn't need all that abstraction and that complexity. And the problem is that this abstraction and this complexity looks engineering. It looks like, oh, he's such a fancy engineer. But and that makes it very hard to detect. But then if you have too much complexity that is unnecessary, it will make things slower. Slower to work as a team, not slower to run, slower to work and to think about. If you have any abstraction or any complexity, it should have a specific reason for it to be there. And the reason should not be that it's written in some book. It should have like a very specific, meaningful reason for your specific use case. It makes tests faster. It makes users happier. It enables another feature. It should not be that someone say it's a best practice and that's the only reason. You can also optimize for the evolution of the code, not for the architecture. It's better to being able to refactor the code that you have than having a pristine first architecture. For that, you can use types. The types are needed mainly for the inputs and outputs of functions and for classes that define the shape of data, like data classes or pedantic fields. You don't need to add types to every possible variable. It's just in these specific points, and then the editor will be able to help you understand all your code better and make sure that your code is correct. You can also use tests, and this will help you ensure that whenever you refactor something and you break it, you can see why is it broken and how to fix it. These tools are what will allow you to be able to refactor faster and better. You can also try to limit magic keyword arguments. things that will behave in a sort of magic way depending on what is the text that is written in the keyword argument. Because the editor cannot help you with that. The editor cannot tell you this is correct or this is wrong. It's just some magic argument that you have to remember how it's written. You can also limit the strings that have dots in the middle that are supposed to be things to be imported, because the editor cannot help you figure out if they are correct or not. Also, other types of magic strings, like having SQL inside of strings, having other different types of languages just inside of strings. The editor cannot help you figure out if you are making a mistake, if the syntax is correct, if this is actually correct or not. So it makes it more difficult to refactor and evolve the code. So simple is better than complex. This is the sense of Python, and that sounds intuitive. But the problem is that achieving simple is harder than achieving complex. Building complex is actually easier. The first thing that you can imagine how to solve something is probably more complex. If you put more time and more effort into trying to think, is there a simpler way we could actually do this? Or can we avoid doing this in some way? Can we make it even simpler? That takes more effort. But that effort, the idea is just to build the simpler stuff. Just like put the effort, because that is the price of cool products. They are just simpler. Achieving that simplicity is harder, but it's worth it. Now, tips for managing a large project. The workload in open source projects, as they keep growing, is this size. And the workforce is this size. It's a lot of work. Open source is normally handled by 1 or 2 developers. Even the big projects that you know are handled by a handful of developers. There's not a lot of people doing open source. And the community is always made of specific individuals. So when you say the community will take care of it, you should be thinking, I will take care of it. You should be thinking, you are the community. And how can I be responsible for this community and for this thing that I am trying to make? So try to be gentle and kind with the people that are doing the work. It's the same with conferences. It's a handful of people doing a lot of work. So try to be kind to these people. And try to automate as much as possible, because there's just so much work that it doesn't make sense to keep a lot of time doing routinary work that could be automated. In the case of FastAPI, I have the chance and the luxury of having a team of people that can help with things in FastAPI, but this is not the case for the most projects. So be kind to those people that are putting all that work. Let me give you an example. FastAPI has a lot of documentation in Japanese. I don't speak Japanese, and I am trying to speak slowly so that you can hear in Japanese the translated version live. It's difficult speaking slowly. This documentation, I cannot write it. I don't speak Japanese. This has to be by the community. And for example, these are the people that have done most of the work for the Japanese translations. Is any of these people here? I don't see anyone, or they are very shy. But here's a big thank you to these people for all the work that they have been doing to help all the Japanese community have the FastAPI documentation in the local language. This is work that has to be done just by the community, and is specific individuals, as you can see. Now let's talk about the issues in open source projects. 90% of the issues reported in an open source project are actually errors in the user side. And if you allow it, if you are building an open source project and you let them, they will declare it as bugs in the framework. I have also done it. Say, hey, there's a bug in this tool that I am using, but it's actually my own error. In many cases, they don't have enough information. So you can use templates for those questions and those issues. These will help you guide those users into giving you all the information that you actually need to be able to help them. For FastAPI, for example, I have the FastAPI experts, and this is something that you can also try to apply. This is highlighting the work that is done by the people that is helping others with the questions. It's not necessarily intuitive, but most of the work that needs to be done in open source is answering questions from others, helping others debug their own code. This is most of the work that needs to be done. And it can actually be done by anyone that knows how to use a tool. So you could be contributing to any of the open source projects that you already use and you already know, just by going to the GitHub discussions and forums and helping others with those questions and those discussions. There are also drive-by PRs, so pull requests that are sent by people sort of randomly. They could have many files. Sometimes there are multiple features at the same time. Sometimes the tests are just failing. Sometimes the tests are not really covering the feature that they are trying to implement. Sometimes the pull request doesn't have a clear objective. Sometimes there is no clear use case for the specific pull request or the feature that they are trying to add. Sometimes it's just like out of scope for the project. Sometimes the PRs that are sent have conflicts with the future plans that you have for the project. And sometimes the PRs are, like Will McGugan said, a cake PR or a poopy PR. This is how this works, or what he meant. A cake PR is a pull request that you can receive, eat, enjoy, and that's it. A poopy PR is one that you can receive and you're happy about it, but you have to maintain it for the rest of the poopy's life. You have to feed it and you have to scoop its poop. And some of those are very cute, but make a lot of poop. And this is hard work. This is all to say it's important to learn to say no. In many cases, you just have to learn to be able to say no and learn how to be polite and how to explain the reasons. But it's important to be able to say no, because otherwise it's just infinite work. There are also sometimes drive-by reviews, people that come and review pull requests without necessarily all the context. They could make reviews about style, and you don't necessarily need the style that they are suggesting, or about the structure with some personal opinions that are not necessarily the opinions that you want, or maybe asking for extra changes or extra features that you are not really wanting to have in that PR. Or maybe there is one single line change, and they are approving that, but they are not necessarily reviewing the other lines that didn't change, but that need to be reviewed, because that changes how the system works. In many cases, they will come and say, why is this not merged? It's only one single line. But you have to check if it's actually working. You have to check the other 1,000 lines. So you can write documentation explaining others how to help with the review process, so that they can help you with the things that actually help you. And you can, for example, tell them, check, does this actually solve the problem? Does it have tests? Now the next tip. Yes, gain. Yes, pain. Have you heard there's a saying, no pain, no gain? Well, now there's a new one. Yes, gain, yes, pain. The bigger the impact that a project has, the higher the chance of bitter people, and the weirder the haters, and the weirder the complaints. And that's success. There are some dark places, like Hacker News, or Reddit, or some forums, and you might want to try to avoid them. Let me give you an example. Someone said, I like FastAPI, but I hate the documentation. If anything is a red flag for me, then it's the use of emojis in the documentation. That being said, I tried it and it works pretty well. I particularly like that it's ASCII. So it worked, but this person really didn't like the emojis. Someone asked, emojis in the documentation? Can you please elaborate on why this is a red flag? Then they came back and said, it's clearly a sign the devs consume hard drugs. I just said, I'm screenshotting this. It was just fun. We got to laugh. And that's success. Great success. In case you are wondering, I do drink lots of coffee. Now, here's the point. Your attention is valuable. So reward your attention carefully. Your attention brings visibility and importance to the thing that you give your attention to. If you're feeling like this, if you're receiving bad feelings with something, remember that not everything deserves your energy. Now a little bit about the culture. Don't try to convince entitled, annoying people. If you convince them to use your tool, to be in your community, they are going to be entitled and annoying, but closer to you. Keep toxic people away. In most cases, the bad ones fall on their own. In most cases, you don't need to engage. You just don't need to put your attention into that, and they will just get bored and leave. But still, you have to protect the community. It's a responsibility that you have when you have a community and when you create it. In particular, when they are attacking others in your community. And you need to take action when needed. If someone is attacking someone else in your community, it's important to go and say, hey, this is not okay. Don't do that. Most people are good. And in many cases, you can just focus on build things. And you don't need to worry too much about that. But it's important to have it in mind. But in most cases, you can just focus on solving a problem. Now, when you receive feedback, positive feedback, and you are happy about that feedback, save it to read it later on bad days. This is actually useful. If you're feeling down, if you're feeling sad, go and read that positive feedback that you received before. That will make you a little bit happier and with a little bit more energy to go and continue solving problems. About sustainability. Sponsors are friendly. If you are building open source and you're considering sponsors, sponsors are friendly. It's not necessarily intuitive, but they are the friendliest. Small sponsorships will make you happy, but they don't necessarily sustain. They don't necessarily buy you food and clothes. And sizable recurrent sponsorships are more rare, and mainly when they are receiving something extra in exchange, like a badge in the documentation, consulting time with you, something extra apart from the open source that is already free. In most of the cases, it becomes this sort of transaction. You're kind of selling something, just receiving sponsors because there's this open source. Now just give me money just because is not as easy to achieve. And if you're just thinking about like the economics of it, the open source becomes a distribution or a marketing channel or something like that, so that they will give you money for something extra, and then they know about that something extra because the open source. But receiving money just because of the open source I haven't seen it work very well. And I want to introduce you to the boss ticket factor. You might have heard about the boss factor, which is what happens in case Sebastián gets hit by a boss. What happens to FastAPI? Oh no. Remember that 1 or 2 open source developers are maintaining most of the open source projects you use. In most of the cases, it's just a handful of people doing the work. 1, 2. In the cases they are lucky, they have 2 people. In most of the cases, it's a single person. This is the case for most projects. even the bigger ones. When you check the projects that you use the most, in most of the cases, it's just a handful of people doing all the work. So worrying about the boost factor can be like worrying about the poisonous frog. Like you are gonna go out on the day and then you're gonna touch a poisonous frog and you're gonna die. Instead of worrying about washing your teeth. So it's like being like this fellow. And we only have poisonous frogs in Colombia. You don't have them here. You don't have to worry about them. But you all have teeth, and you should wash your teeth. This is important. This is more important than worrying about a poisonous frog. But worrying about the boost factor is like just worrying about the poisonous frog and not about washing your teeth. So here's the idea. Whenever you think about the boss factor, I want you to think about the boss ticket factor. Who is paying for the ticket? It's like we are all in one boss of open source, and there's someone that is driving. Why is this person driving the boss? What is the thing that this person gets out of driving the boss? You don't want to be riding a bus, and suddenly the driver gets tired and just leaves you there in the middle of the highway in a bus. That's not ideal. So think, who is paying for the ticket? What is the ticket? What is the value this person is getting? Remember that airplanes have only 2 pilots, and that is enough. But they have lots of tickets. They keep flying because they have lots of tickets, not because they have many pilots. So there should be some value, some objective. It could be just the satisfaction, and that's fine. But if we are depending on someone spending the nights and weekends on something, that's not necessarily sustainable. So think about what is the value that this driver will get out of providing that open source. It could be recognition or job perks. It's easier to find a job if you have open source. It could be that they are selling you something. But whenever you are thinking about the boss factor, I want you to think about the boss ticket factor. And think about these open source developers that you are depending on. What are they actually getting out of you using the tool? What are they getting for them to keep doing that work? And now I'm going to tell you a little bit about that. The next problem that I'm solving, which is sort of a shameless plug. I wanted to make FastAPI very simple to build and to build applications, and that was the idea of FastAPI. But then when you want to deploy it, it can be very complex and overwhelming. So I wanted to reduce that complexity as well, to reduce that problem and make it easier. So I started FastAPI Cloud. You create a simple app and run one command, and then we handle the rest, and it's just deployed for you. The idea is to apply all these ideas that I have been showing you to one specific problem. In my case, I'm applying it to the problem of deploying FastAPI, but you can apply these ideas to any problem that you want to solve. This is the invitation of this talk, to go and solve a problem. If you remember anything, it's just to go and solve a problem. Nobody expects the end of the talk, but this is what I have for you. Thank you very much. I think I managed to speak slowly and say everything. We might have time for questions, maybe.
はい、それではですね、Q&A をさせていただきますね。はい。ですね、ご質問のある方はそちらマイクのところまで進んでいただいて、マイクでお話しいただきたいと思います。
I will also be around tomorrow, so you can also ask questions later. And I will also be at the party afterwards, so you can also ask questions there.
日本語でもいいですか？日本語で。セバスチャン、ありがとうございます。 すごく、感動するスピーチ、本当に、楽しく、私2回目なんですけど、聞かせていただきましてありがとうございます。すごく、なんて言うんでしょうね、すごい正確にいろんなことを正しくやっているというふうに私も思っているんですが、どうしてそのふうに考えがそこに行き着いたのか、なぜ今のような行動を考えられるようになったのかっていうところがすごく、疑問でして、もし、教えていただければと思っています。
It's not necessarily that I had this philosophy and then I tried to follow it. I think I was intuitively following it, and then I realized that there was this set of ideas that I was trying to follow, and I tried to put all that in the presentation. But I was just doing that before writing it. I think an important thing that happened was that I was avoiding building something new. I was trying to find what was the solution for the problem that I wanted to solve, instead of wanting to just like build something new. And the focus on specifically solving a problem, I think that was very important, because that led to waiting for a long time until it was the right moment to actually build something that was useful.
ありがとうございます。
Thank you for your talk and every day your hard work. As one of the fast API user, me, I want to say a big thank you for you. And my question is, the first one is how do you motivate yourself? Because as you talked, it's really, really hard work to talk with issues or like PRs. All of them are not so clean and understandable and humble. But as you said, how do you maintain your motivation? And the second one is for example, the Django is organizing like big organize via organize. But feel the fast API is hosted by you. Of course, there are some communities, but not so big organization. So do you have any motivation to have organized? The first one is about your motivation. The second one is do you have any plan for the organization?
About the motivation, handling issues and requests by users, in many cases, is very hard. Because people come to GitHub and to the questions and to the issues, in many cases, with their problem and with their frustration.
Yeah.
And they can show their frustration very vividly. In many cases, it needs, taking a walk and just like breathing, things like that. But it compensates a lot that when you interact with people in other areas, when they are using your tools. For me, being in these conferences and seeing people telling me, I'm using FastAPI and it was useful, that was cool. It makes me so happy that it compensates like the feeling of sadness and annoyance when I have to deal with like all the other stuff. So interacting with people, sometimes online, on Twitter or LinkedIn or in conferences, for me, I think that is very valuable. That about the motivation for me. About the organization, in the case of Django, they have a big organization.
Yes.
They have, I think, a committee that takes decisions. And then they have, I think, 2 fellows. So it's 2 people that are reviewing the pull requests and reviewing and deciding everything. They decided to take that path, and I think like that has worked for them. In my case, there have been so many things that I still want to do with FastAPI, that I still want to finish like the features and the ideas that I have been wanting.
Yeah.
And now that I have the chance to be able to have people on a team that I can pay them to just work on these tools, I think it's a great opportunity to keep sustaining the tools and to keep building more and more tools and producing more. So I think, like both approaches are perfectly valid, I will think. For them, I think the important thing is to see what is the boost ticket factor? What is the thing that they get to do it in that way? How can they get sponsorships for the Django Software Foundation? And how are the companies actually sponsoring that work and making sure that it just keeps working? And like in my case, like now that I'm building this product is perfectly aligned with the open source, because the more people that can successfully use FastAPI and all the open source, the more potential clients, let's say. In the end, for me, it's sort of a way to inject more funding into open source and to build more things. But the important thing is that the idea is to make both things align so that I can make it sustainable for the long term.
Thank you. Thank you for your presentation and again, your hard work. Thank you so much.
Thank you.
First of all, thank you for presentation. I'm really impressed that the innovation is the result of the solving a lot of the issues. My question is, what is your important point to find what issues is the most important to be solved? Because you said importance of the solving small issues, but there's less information about the findings. What is the most important issues?
I think the best is when the problem annoys you directly. When it's a problem that affects you directly, that is the best situation. Because the thing that you build, you will be the same person that can know if it's actually useful or not. In my case, I built so many things for my parents that were not useful for them, because they are not systems people. They don't like computers. They like to write on paper. And I built this distributed system for managing clients, and they were like, where are my paper colors? I don't like it. So I built many things for them that in my mind will solve their problems, but because I was not constantly checking with them, is this useful or not? Then I spent so much work in something that was in the end actually useless. So if you have a problem that is important to you, that is the best scenario. If you are solving a problem for someone else, it's super important to throw them a Pokeball and have them very close to you, checking if the solution is actually useful and iterating on the feedback that you get from them. The idea is you will have a feedback loop. So you will have information telling you how useful is the thing that you are building. If you are the owner of the problem, the feedback loop is super short, is almost inexistent. If you are solving a problem for someone else, the feedback comes from that other person. So try to make that feedback loop as short as possible and try to keep that other person very close to the solution that you are building and keep evolving that solution with their input.
Thank you. Reviewing myself is the first step to the finding the issue. Yeah. Thank you for answer.
Thank you.
Hello. Thank you. Thank you so much for your excellent talk today. It was really insightful and got into the soft skills component, which I think is very important. I was hoping that you could expound a bit more on the economics of open source projects and maybe a bit more about the business model as a marketing funnel for companies and how that tailors into consulting and other sources of revenue for the open source developers.
Yeah. I have not seen a silver bullet that works for everyone. For most open source projects I have seen, there is some strange way that they are trying to make it work. In many cases, it's just, the free time of the developer and weekends. I don't think that's fair, because then we are taking something for free that is generated from that person not paying attention to their kids and their their partner or things like that. But that is the case in many cases. So it's always a very delicate balance that is in most cases not really balanced. I think that also finding what is the right thing to build is sometimes difficult because in many cases people will build a tool that is the commercial tool that conflicts with the open source. So for example, there's like an open core and then the premium side has more features. Then every new feature will have to go through the problem of should this go to open source, should this go to the premium? And if it goes to open source, then more people have something for free. If it goes for premium, then the open source thing is not really as good as it could be. And that is very difficult to balance. I avoided building a company for many years because I didn't have an actual product that I thought I could sell. Every time I could come up with something that could be useful, it just had to be open source. Like that happened with Typer, SQL Model, Asyncer. All of that stuff just had to be open source. So that's why it took me so long to actually start a company and start a product. When I found something that would align well with the open source, that the better that one thing goes, the better the other also goes. I think that is the sweet spot. The only thing is that it's so hard to build that product. but yeah, I think that is like it's an actual situation, and I think one thing that we can do as developers using open source from other projects is put a little bit of pressure to the companies that we are working for. And we can just ask the manager, the engineering manager, or like the manager, whoever is like the head, do we sponsor anything in open source? Just ask that question. You don't have to say, we have to sponsor open source. Just ask, are we sponsoring anything in open source? Or if you are in job interviews, you can ask the company, how much time from the company do I get to work and contribute to open source? Or you can ask, how much time do I get to contribute to the open source projects that we are building on? In the end, it's useful for the company because the company is building a product that depends on open source. But in many cases, like the upper management levels or finance, or they think, it's open source, it's for free, it's already done. So you can just take it for free. But we, as developers, we can just ask about it, and just by asking about it, it will keep growing this idea that open source is something that should not be just taken for granted. I think that is something that we could do about it. It's definitely not a solved problem.
Cool. Thank you so much.
Thank you.
In Japanese、日本語で失礼します。素晴らしい話だと思いました。そのファスト API という8万スターを超える作者だからこそ話せる話だなと思って、本当に話してくださって、またファスト API 作ってくださってありがとうございます。X の方でもなんか私と同じように気になってる人がいるようなんですけど、マスコットが非常に可愛いなと思ってまして、スライド中に出たウーパールーパーのようなマスコットはファスト API と何か関係があるものなんでしょうか？
It was actually the idea of one of the teammates from the company, Alejandra, the person that does all the UI, all the interface for the front end of the cloud product, and also manages a lot of the open source. She had the idea we should have a mascot, and this is actually an animal that exists. It's called an axolotl, and it looks like a Pokemon, but it's actually an animal that really exists, and is in Latin America. It's not in Colombia, it's in Mexico, but still it's very cool.
Thank you.
Thank you.
Are その他にご質問ございませんか？ Are there any other questions?
I will also be on the corridors later and tomorrow, so you can just ask me whenever. Just grab me and say, I have a question.
はい。それではこれで終了させていただきますか？このままクロージングに行きますか？ OK。はい。 それでは、はい、ありがとうございました。Thank you very much for your talk, Sebastian. 皆さん大きな拍手をお願いします。